Hi everyone, welcome to AWS Summit Online. My name is Yang Ming and I'm a solutions architect here at Amazon Web Services. Many years ago in software development projects, security-related checks and enforcements are usually only added in the later stages as projects last for months before being released. However, in today's world, this is no longer the case. The introduction of DevOps automation and tools has dramatically changed the velocity and frequency of development cycles. This means that your security models need to keep up with the pace of change, and you can expect greater security automation is required to help to scale your teams to move fast and yet remain secure. In today's session, I'll be talking about the 6 types of AWS IAM policies that can help you in your DevSecOps journey. I'll start with a quick introduction of DevSecOps, least privilege principle, and how it relates to identity and access management. Then I'll talk about the various types of IAM policies, what are they, and how you can use them to apply in your DevOps pipeline. We will then finish off with a quick demo to see how all this look like in action in the AWS console. So I'd like to start by quickly talking about the term DevSecOps. I'm sure many of you have already heard about this term, so I'm going to just quickly summarize what this means without going into too much details, as we can spend a whole lot of time on this. While the principles behind DevOps itself revolve around automation and infrastructure as code, with DevSecOps, there is a greater emphasis on all the things with security and compliance to get checks in as early as possible and then automate as much as you can. So there are a lot of talks about DevSecOps out there on how to do vulnerability testing, how to perform compliance check, how to use secrets management tooling, and all that sort of stuff. The main idea is to prevent any security vulnerabilities or flaws from getting downstream into your production environment, where things tend to get trickier and costlier to fix there. You want to catch them as early as possible, sort of the shift left kind of mentality. But today, I want to focus on one key aspect that most customers tend to neglect when setting up their DevOps pipeline, which is the security of the pipeline itself. Nowadays, with this wide variety of tools and so many roles out there, it introduces complexity which make you wonder, how confident are you with the access controls you have in your pipeline? More specifically, how can you ensure that you have the right people or applications accessing the right parts of your pipeline? This leads us to the topic on least privilege principle. Essentially, granting only the permissions required to complete a task. Many times, out of convenience, in order to quickly move fast and build up their stacks, we see customers set up permissions that are often far too open. It is very common that developers are simply given full admin rights. This is sometimes okay, in an isolated development environment, but what happens if the pipeline is in a shared DevOps account? How do you let your builders have the freedom to do their thing? Sometimes to experiment, perform debugging, tracing, yet be assured that dangerous actions, many times unintentional, are being prevented. I will be talking about how you can scope down these permissions with various AWS IAM policies to help you improve your security posture. Since this is a level 300 session, I'm going to assume that everyone is already familiar with IAM, what are users, roles, and permissions, right? In this mental model of identity, access, and resource management, the who consists of the name, credentials, metadata, essentially the principles, right? The can access is about the policies and permissions, right? Whether to allow or deny. The what is about the resources, which you can identify via groups or tags. If you provide another view of that slide, we can see that identity comes in to a central policy point. Alongside it, there's also metadata about the resources that comes in. A policy administrator pushes in policy information, and it's not magic, right? It's just a bunch of rule-based processing that eventually tells you if a request is allowed or denied. And as mentioned, we're going to be talking about several types of IAM policies, and primarily, there are 2 main types here, grants and guardrails. So grants are the policies that gives permissions, while guardrails set the maximum permission for your accounts or environment. Note that guardrails do not grant any privilege, but narrow down the maximum privilege possible. You can set up a bunch of guardrails that allow permissions, but if you don't have any grants that allow any permissions, the permissions are then denied for the principal. Essentially, you'll want to use both grants and guardrails together. Today, we'll be looking at these 6 types of policies. I'll go through some basics on each of these types, then quickly jump into a DevOps pipeline kind of use case to demonstrate how these policies can be used. Now, when you have IAM policies attached to an IAM user, group, or role, we call these identity-based policies. These policies let you specify what that identity can do based on the permissions defined in the policy. You can use predefined managed policies or attach them inline. Identity-based policies do not have a principal attribute, so they assume that the IAM role that is attached to it is the principal. So users can also federate their identity with an identity provider, such as Okta or Microsoft ADFS, right, to assume a role with the attached policy. When you have IAM policies attached to a resource, we call it a resource-based policy. With resource-based policies, you can specify who has access to a resource and what actions they can perform on it. There are only several resources that supports resource-based policies, right? More commonly, the ones are Lambda, S3, Secrets Manager, and KMS. Only inline policies are supported for resource-based policy. Now, a resource-based policy has an advantage over identity-based policies because it enables you to grant access to principals from different accounts. And then we have access control lists, ACLs in short, which are service policies that are similar to resource-based policies, but they do not use the JSON format. ACLs allow you to control which principals in another account can access a resource. They cannot be used to control access for a principal within the same account. For example, in S3, you can use ACLs to grant basic read or write permissions to other AWS accounts. Like if a bucket owner allows other AWS accounts to upload objects into his or her bucket, permissions to these objects can only be managed using object ACL by the object owner. In other words, if you want object level kind of privileges, usually in the case in a shared bucket with different object owners, use ACLs. If you're okay with bucket level, use resource-based policies. On to guardrail type of IAM policies. A permissions boundary is an advanced feature in which you set the maximum permissions that an identity-based policy can grant to an IAM entity. When you set a permissions boundary for an entity, the entity can perform only the actions that are allowed by both its identity-based policies and its permissions boundaries. This effectively limits or reduces the scope of what the identity-based policies define. A very good use case for permissions boundaries is in the scenarios of delegating permissions. As an IAM administrator, you don't want to be the only person that is able to grant or create IAM roles and granting permissions. Most of the time, you find that you become a blocker when developers need a certain permissions for their applications to run on, and they need to wait for you to create them. So you may end up delegating the rights to user or role creation to the developers. Then what you realize is that developers cannot effectively create an admin role and assume all the white powers of an admin and do bad things, like buy reserved instances or turn off CloudTrail. Permission boundary is to help with that. What happens is that you, as an IAM administrator, you can define the guardrails by setting up this boundary of what they can or cannot do. You can then allow developers to have the ability to create IAM roles for use with their applications, but with a condition that for every policy they attach, they must also apply permission boundary on them. And because the effective permission is the intersection of both the identity policies and the permission boundary, you effectively limit what these new users or roles can do that were created by the developers. Even with administrator permission attached in a role, they still have denied permissions to all the bad actions. Very similar to permission boundary, session-based policies are advanced policies that you pass in a parameter that points to a guardrail policy. When you try to create a temporary session for a role or federated user using the assume role API operations, either via CLI or via an identity provider. The difference with permission boundary is that these additional guardrails are only applied upon assumption of the role via a parameter. Session policies are not commonly used, but in fact can be interesting to apply in very dynamic scenario. Think about a scenario where you could reuse a particular role and only apply slight variations on it upon login. This can actually help your administrators to reduce the number of roles they need to create and manage, since multiple users can assume the same role yet have unique session permissions. Again, The effective permission is the intersection of both policy types, which will effectively limit the scope of what the identity-based policy is defined. On to organization SCPs, right? If you're familiar with AWS organization, you will know that there is a management account right at the root level, and you can create organizational units or OUs, which are essentially just groupings which you can put your AWS accounts in. Note that only the triangles here are AWS accounts, right? These boxes are just OUs, which are just groupings. SCPs allow you to attach a policy at the OU or root level, and as a guardrail policy, specifies the maximum permissions for member accounts in the OU. In this way, you can restrict which AWS services, resources, and individual API actions the users and roles in each member account can access. If you put these policies together, you will see that the effective permission is the intersection of all three policy types. The identity-based policy needs to provide a grant for the access, and they must attach a permission boundary, right, which limits the permissions defined by the developers. Additionally, SCPs add in another layer at the organization level to further limit the scope of the permissions. Now let's switch gears for a bit to talk about a typical DevOps pipeline. Right? Every pipeline you see out there nowadays will contain these four main stages. Right? In the source stage, developers will typically share a code repository hosted on a version control system such as GitHub, Bitbucket, or AWS Code Commit. Once they have pushed in their code, event-based triggers will move the pipeline across to the build stage. The build is usually run on one or more build servers, right, that will pull the latest source code, run build commands to put the application together into an artifact. This will then kick off a series of automated tests to ensure that the application passes the various test case scenarios. Right? There could also be security checks performed, such as image scanning at this stage. Finally, when the application passes all the tests, it gets deployed into a UAT or production environment. So let's see how this 6 IAM policy applies in this pipeline. In many cases, especially in the cloud, developers interact with the source repository by authenticating themselves through an identity provider. The identity provider establishes a trust relationship with an AWS account. I'm going to start circling the areas where I'm referring to in the architecture diagram for better clarity. Now, in AWS IAM, you would have created a role in which your developers can assume when they authenticate themselves via their identity provider. The roles will have IAM policies attached which will determine the permissions the developers are granted. In the build stage, this is where your application is being built. Right? This can also be an EC2 instance running Jenkins build servers, for example, or in this case, code build. Right? Very often when you promote applications across environments from dev to staging to production, you want to prevent developers from having access to sensitive credentials, such as database connection strings or passwords. These sensitive credentials, also known as secrets, can be automatically retrieved from a secure storage, such as a parameter store or secrets manager. They are essentially stored as a key value pair, right, encrypted by KMS. Right? You can attach EC2 instance profiles onto the build servers, which will assume a role trust policy for the EC2 service to access the secure storage to retrieve the secrets programmatically and append it into the application configuration. Many times, secrets are stored in separate AWS accounts, so you can attach resource-based policy directly on the secrets itself, which will indicate which principals across AWS accounts can access them. In the test stage, you could have several test reports generated and sent to a separate S3 bucket in another AWS account, which may be accessible by other users, such as QA, security, or audits. You can use object ACLs to grant access to different grantees that may require access to these objects in that bucket. Once application passes all tests, it may trigger an approval stage, right, which requires a release manager to approve workflow before the application can be deployed in UAT or production. Session-based policies here can be used for some interesting use case. Right? In some cases, organizations have company-wide kind of a code freeze or deployment blackout hours. Right? It could be during an ongoing sales promotion, a new product launch, or holiday season, right, that deployment could be risky. Right? So identity providers can allow adding an additional inline session policy when performing assume role with SAML. This can dynamically limit the ability for the federated user to perform deployment approval actions or even git push actions using session-based policies. Another guardrail you can use to limit permission scope is permission boundary. right? This is commonly used alongside a managed policy so that you can scope down permissions further than what was provided out of the box. Let's zoom out the picture further to take a look at the pipeline in the AWS organization context. You can use organizational SCPs to further limit the scope of services accessible. For example, if your workload only runs in the Singapore region, deny any operations or actions outside of the Singapore region. Right? You can also prevent accounts in the OU to make changes to sensitive services, such as CloudTrail, config, or guard duty. Let's jump into a quick demo to look at how all these look like in the AWS console. Before we begin, let me quickly introduce to you what we have here. I'm running a web application called Mythical Misfeats, which is a fictional pet adoption site. Users can head over to the site to view the various pets, look at their profile, adopt them, or click the like button to like them. Let's check out the architecture for this. The application is running on Fargate, which serves some of the backend web APIs, such as the adopt and like action, which will send a counter to a DynamoDB table. The application architecture here is not really the focus, right? What I really want to show you is the CI/CD pipeline on the left. The application is connected to a fully automated CI/CD pipeline orchestrated by Code Pipeline. There is AWS Code Commit as a source code repository, and we have AWS Code Build as well for building of the application. And moving to security tests, we have Claire to help scan our container images for vulnerabilities. Finally, ECS will deploy the application into an ECS Fargate cluster. I will be moving around this pipeline to show you some examples on how you can implement the 6 IAM policies as discussed earlier. Note that this is a very simplified demo just to demonstrate the various policy types and how they can be used here. It doesn't mean that you need to implement all of these in the exact same way in your environment. Let's start with a very common scenario, right? Let's say I'm a new IAM administrator here and I've created an IAM user for my developer, which is called demo developer. I don't really know what the developer needs, so maybe let me just attach a power user role for him. Right? So as you can see here, I can either attach the policy directly to the user or group, which is why this is known as an identity-based policy as mentioned. So power user is an AWS managed policy which gives a lot of permission to the role. In fact, it uses an allow not action statement, which effectively gives permission for everything except for administrative actions like IAM and AWS organizations. So let's now quickly switch to the developer user. So let's say that developer needs to work on developing for serverless function, right? He will go to the Lambda console and try to create a function. However, because the role does not allow any IAM permissions, he will quickly realize that he cannot create the required IAM roles for his applications to assume. So feeling frustrated, he calls up the IAM administrator to give him IAM permissions. So in order not to become a blocker, the IAM administrator agreed, right, and created a new policy and imported the power user managed policy into it. So from there, he also removed the IAM restriction and the policy is saved with a name of a custom power user, as you can see here. So in order for the developer to use this, he will then need to attach this new policy and detach the previous power user policy from the developer IAM user. So as you can see, you can quickly make use of pre-built AWS managed policy to customize it to your requirement. So once you attach the new policy and detach the policy, the developer will now have full IAM permissions, right? So now going back to the developer again, he is now very happy, right? He can create any IAM roles and attach any kind of policies without restrictions. So he starts to do some bad things, right? Like create a cross-account role here, right? So he can perhaps invite his friend in. The developer knows his friend's AWS account ID and created a cross-account role, right? To make it worse, he attached an administrator access policy, right, to the cross-account role as well. Let's call this bad person role, right? And there, right, we now have a cross-account role with full admin rights. So let's switch to the bad person, right, which is the developer's friend. Let's try to assume this new admin role into the account and see what this guy can do, right? So he can actually go to CloudTrail and look at the trails in the organizations and even make changes to it, right? So he can actually stop the logging of the CloudTrail and even delete the trail, right? So nobody will know what he did in the account. So there are many other bad things, right? Such as going to things like EC2 reserve instance, right? So you can actually purchase a lot of reserve instance, add them to the cart, and and check them out, right? Which will essentially create a very huge bill for the organization. So as you can see, once IAM create role permission is given, you will have a lot of issues. Let's see how permission boundary can help with this. Let's go back to the IAM administrator, right? In the first place, giving power user to the developer is already too much permissions granted. Let's try to scope down the permissions here by using the least privilege principle. Very likely, the developer doesn't need to access organizational-wide services such as CloudTrail, GuardDuty, AWS config, and etc. Right? So we will also put back the IAM restriction for the custom power user, put it back IAM start. Right? And we will also add other restrictions like billing and RIs as mentioned, right? Along with CloudTrail and GuardDuty and the rest. So what we want to do now is to allow the developer to create and attach roles in a controlled manner, right? So let's give him an IAM read-only permission so that he's able to see the other users and roles in the account. Also, we should let him create, attach, and detach roles for his applications to work properly, right? Notice that something different here is the additional condition that mandates attaching a permission boundary called boundary for developer, right? Which is a pre-created one here just to demonstrate, right? A permission boundary is also like every other IAM policy, right? And this one here that we have pre-created, so it allows common actions like S3, CloudWatch logs, code build, code pipeline, and Lambda as well. So let's head back to our policy. So the final thing that we will be adding here is the ability to pass role to AWS services, as well as limiting the roles they create to start with the word bounded, as you have seen, right? So let's save and update this permission. And now let's go back to the developer. Let's try and see if he can still do the same bad things again, right? Nothing can stop him from creating a cross-account role as long as he has the AWS account ID of the other party. Again, he will try to attach an administrator access policy. Let's give it a name, bad person. So if you try to save, there will be an error. Right? Recall that we have added an additional condition that he will need to attach the permission boundary. So he will need to attach this permission boundary for every role that he would like to attach, for every policy that he would like to attach to the role, right? So let's attach the boundary that we have specified, and let's try and save. There's an error, right? So recall that we have also mandated that the roles must start with the word bounded at the front, right? So bounded dash something. And now the role creation is successful. Next, let's look at resource-based policies. A very good use case for resource-based policy is for resources that are residing in another account. For example, you can see that I have some resources provisioned in this account, which I call it as a security account. So let's jump into this security account to take a look, right? So this is the secret manager console, right? Where you can store your secrets and they are identified by their resource ID or ARN, which you can see over here. So you can also view the value of the secret, right? So I have a plain text value of hello world here, but you could store other things, right? Like database passwords, tokens, or login information. So there are a few ways the application can interact with Secret Manager to access these secrets, right? So in ECS itself, in the task definition, you can actually specify environment variables, right? And you can set this as the secret value, which is retrieved from Secret Manager. So if you head over to the container details, you can find the environment variable, and you just need to specify the ARN of the secret, right? So with this, the ECS task will retrieve the value directly from Secret Manager so that you do not have humans accessing it. Right. Alternatively, in the application build stage, you can also append these secrets into your application config as well. right? So code build also supports secret manager natively to help you retrieve the secret. So you just need to set up the build spec file to point to the secret manager via the ARN as shown. So I'm going to quickly show you what happens if a developer tries to print out or echo the secret value into the logs, right? So I have already ran this build with the echo command. So if you were to take a look at the code build logs, so you can actually see that the secret is actually being censored from the logs. So if you're looking to set this cross-account secrets access, right, there are three things that you need to do to provide the correct permissions, right? One, the secret itself should allow the principal to access it, right? So this is the resource-based policy that we spoke about to provide your main account with permission to execute get secret value API for this secret. So the second one is that the secrets are encrypted with KMS, right? Key Management Service. And you also need to grant access to your principals, which is the main account, to use the KMS key to encrypt and decrypt the secret. And thirdly, right, the role itself needs to grant access, right? So this can be the ECS, task, service, or code build role, which I can actually show you in the IAM itself. When I go to code build, I find the role that is being used to run the build, right? So the role that's used to run the build needs to grant this access to the secret over here, as well as to KMS to decrypt the keys. Moving on to ACLs. Usually in a pipeline, this is used for managing of files such as build artifacts or reports that you want to send to another bucket and yet retain full control over the permissions of the file, right? So in our case here, I have a clear container image scanner in my pipeline that kicks in after the build stage, right? The reports and finding and outputs can be written into a file and uploaded to an S3 bucket in a separate account from here, right? So I can set the ACL to bucket owner full control. So the bucket owner automatically have full control of the file, right? Otherwise, you could also set up something like bucket owner read, right? If you don't want the bucket owner in another account to modify your file, right? So if I view the build logs, right, you can see that the command is being executed and the output is uploaded to S3, right? So you can see that there's a successful message over here that the file has been uploaded. So if I head over to S3, where it is in a different account, right? And I can try and find the file in this bucket over here. There, the file, the report is being generated and stored in the S3 bucket over here. So let's talk about session policy. Right? Session policy is a single JSON policy document that you can pass along when you are calling the assume role API command so that you can limit the scope of your permissions. Normally, when you federate your user identities via an identity provider, it can help to pass that along automatically. So I don't have an identity provider set up, so I will show you how I can do that manually using CLI commands. So just to quickly orientate, I have two repositories on my AWS code commit account. Let's say there is a requirement that each developer can only access the repository that he or she is assigned to. So one of the two, right? So sometimes this can change very often, right? When developers change projects. So for the IAM administrator, in order to avoid having to create multiple similar roles for developers, but with just a small variation, using session policy can be very useful. Let's say I'm on a dev account right now, and I'm trying to assume role into a DevOps account earlier. So this is how an assume role CLI command looks like. Right, the command will have the role. I'll be using the role that we created earlier, bounded developers, right? A session name, which is the like repo access only, and also a policy file as shown, right? Which is the like repo.json over here. So let's take a look at our session policy. We're trying to assume the role of bounded developers, right? Which is a generic developer role used across all the developers. But in this case, this developer only needs to access a single code repository in code commit. So in my session policy, I can provide permission only for that. By attaching this session policy on top of the developer role, it will limit access to only this code repository in code commit. So just to stretch this a little bit further, right? Let's say over the next 1 week, we will have huge spike in traffic and I want to limit developers from pushing or merging any code into production. I can put up deny policies like this, targeting this code repo in the master branch, and also preventing any of these push or merge between 1st Jan and 31st December, as you can see here. So let's try if I can push my code in, right, I will assume the role with this session policy attached, right, by sending this assume role command. Then I will export my credentials from the assume role command. So typically your identity provider will take care most of this, right? So let's see if I can clone the repo, and looks like it's a yes, right? No issue from cloning the repo. So let's say if I can clone another repo, right, which is not the one that I'm allowed. So you can see that there's an error 403. Now let's try and change the code and see if we can push, right? So let's open up one of our code, adding in some comments here. Let's change directory into the folder, do a git add, and then a git commit with a commit message. And then we do a git push. So you will see that there's an error 403, right, forbidden, right, because we had a code freeze condition added between the whole year, right, from 1st Jan to 31st December. So let's try and change this freeze window, right? Before this, let's unset the session first. Okay. So now going back to the condition, let's change the date from 1st Jan to 31st Jan instead of December, right? So which is a date that has already passed, right? So now let's try to execute the assume role command again. The same steps as before, run the assume role command. And then I export the keys. So now let's go back into our folder. We can still pull, no issue. And let's try pushing. And there, right? So it works now. So let's now take a look at the 6th IAM policy on Organizational Service Control Policy, or SCPs. Now, this has to be configured at the management account level in AWS organizations. I'm now logged into my management account. So let's head over to the AWS Organization console. Click on the Policies tab at the top and choose SCPs. So I've already created an SCP over here, right? So let's click in to see more details of this policy. So you can see that the policy has a deny not action on IAM star with a condition, right? So this set of policy will simply deny any other action that is not for the Singapore region, right? Note that some services like IAM has no region and it defaults to US. So I'm going to apply this to the account that we are using, right, which is in an organizational unit, or OU, which is called shared DevOps. So let's attach this policy to this OU. And let's switch the role back into that account, right? So I'm going to try heading over to EC2 console. So you can see on the top right that we are in the Singapore region, right? So everything looks okay. So what happens if we switch to Ohio region? Right, as you can see, there are already API errors that are showing, right, due to permission issue, right? Essentially, the account has no access outside of the region of Singapore for other services. You joined AWS Summit to learn, and you can keep learning beyond the summit with resources from AWS Training and Certification for Security. According to Global Knowledge, IT decision makers report having the most difficult time finding qualified cybersecurity talent, so training has never been more important. We offer more than 25 digital and classroom courses for you and your teams around security, identity, and compliance. You can also showcase your expertise by pursuing the AWS Certified Security Specialty Certification. Thank you for attending my session. My name is Yang Ming, and it has been a great pleasure for me here talking to you, and I hope that you have gained much today. Before you leave, we really appreciate your feedback so that we can better understand the topics and services you would like to know more about, and so that we can build and improve AWS Summit experience for you in the future. So please, do take the time to fill out our survey and let us know what you think. Once again, thank you and enjoy the rest of the summit.